everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch every night, except not the past 2 nights because I was away on business, and almost not tonight because I was on a train back from Portland. I live in Seattle and I was in Portland, Oregon, and what happened was, I guess, the train in front of us hit a pedestrian, which does not sound remotely pleasant for the pedestrian. And I guess when that happens, right, I mean, not a common occurrence, or at least hopefully not a common occurrence, but I'm assuming that there's a lot of stuff that has to go on. First of all, obviously you're going to have the whole medical response. I don't know if the person was all right or what happened, but then I'm assuming that in order for the trains to run again, you have to inspect the tracks and the trains and all these other sorts of stuff. So they basically came on, our train was stopped at Tacoma Station, and they basically came on and said, all right, look, a train in front of us hit a pedestrian. They called it a regrettable incident. That was the word they used to describe it. They were like, there has been a regrettable incident. And so, I'm actually kind of mildly amused by this because obviously I don't have any connection to this person. I don't know who they were. I'm not having like an emotional response or anything to it. But the fact that they called hitting a pedestrian a regrettable incident already kind of hits my satire bone. I'm like, well, yeah, I mean, it's pretty regrettable. That's for sure. Like, if there are things you're going to regret, it'd be like the time I ran over that guy with a train is definitely one thing you might regret. But, I'm like, all right, so I'm like, okay, that's fine. So I'm sitting in the chair. They finish making this announcement, and they're basically like, it could be an hour or two delay, we don't know. It could be a very long time, so we'll let you know as soon as we know something. They undo their microphone thing, right? They stop, and I'm like, okay, I guess we'll be sitting here for a while. 15 seconds later, I mean, maybe 30 seconds, right? But less than a minute. They come back on, and I'm thinking, oh, they must have like gotten word now, like they must have gotten some information back about like, was the person okay? Will the trains be able to run? Whatever. And they're going to tell us about it. No. They come back on and they say, and this is an announcement from the dining car. The dining car is open. So if anyone wants to get any snacks or alcohol, we have alcohol, candy. And so they rolled straight from we hit a pedestrian to this would be a good time for you to take advantage of our dining car. It's like, we ran over somebody, time for dinner. I can't argue with the logic about the efficiency of the situation, but I do feel like at least in most cultures, I guess I don't know that much about cultures worldwide, but in a lot of Western cultures, there's a little bit of period of mourning. Typically, that's sort of implied for respecting people after you run over them with a train, to say the very least. But what are you gonna do? So anyway, I was lucky enough to have my wife sort of tell me, because I was able to use she was still back in Seattle, and I was able to use the Wi-Fi on the train. She was like, well, there's a bus that goes from like not far from that train station up to Seattle. Like, maybe you can go catch it. And so like I did, and I'm very glad I did, because the train, as far as I can tell from looking at the Amtrak site, is still at that station. So unless I streamed Handmade Hero over the Wi-Fi on the train, which, let me tell you, if you think some nights we've had bad streaming problems from this setup, I don't even want to know what that would be like. But that was the other option. So thankfully that worked out. I got home okay, and Handmade Hero can continue. Hopefully we will be able to get through this stream without a regrettable incident. And with that said, let's go ahead and get started. So if you are following along at home and you've pre-ordered the game on handmadehero.org, you can go ahead and unzip the source code to day 80. We're on day 81 right here. So unzip day 80 source code, and that is the source code that I'm starting with right now. And that is what you'll want to follow along with at home. Now, personally, I am feeling a bit drained from this travel extravaganza. I had been supposed to get in at 5:30, which would have had time for me to relax and get ready to do some Handmade Hero programming, but that didn't happen at all. And so I kind of feel like I would like to do something a little light and fluffy, it's just, just to sort of ease into it. So I'm not heading straight from running over a pedestrian with train and having to take the bus to get here on time, blah blah blah, all the way to hard collision detection problem or something like this, where I'm going to have to focus on things too much. So I'm wondering if there's something in this to-do list here that would be a little bit lighter for us to do, maybe something that we could kind of play with, that wouldn't really be a super serious hardcore hour. It'd be something maybe a little bit fluffier. And I don't know. We haven't looked at it in a while. This was kind of just our brainstorming. We're like, here are some things that we might want to do. And so I don't know. What I think I might do, I'm just going to throw this out there. What I think I might do is maybe we should try to add some sort of drawing to the ground. Because it's kind of weird, like when we don't really have much in the way of rendering, and that was fine because we're not really focusing on that right now. But we kind of don't have any real way of seeing the floor. We kind of drew in those trees to show the boundary of a room, but we never actually drew anything for the floor. And so as a result, you go upstairs, you go downstairs, there's no real indication of where the floor is. We're just kind of drawing some representative stuffs so we can kind of see a representational version of what's going on and know that it's sort of working, but that's not maybe perhaps so interesting. So if we wanted to take care of that, I was trying to think of what we could do that would be relatively simple and in the direction of the sorts of stuff that we'll do when we go to the renderer for real. And so if you remember what we've got in that art directory there, the stuff that's already checked in, quote unquote, I guess we're not really checked in, but that's in the project. In that data directory, right, that test2 thing I checked in had some of these like ground splats in them. And of course, you can't really view them in Windows Picture Viewer because for some reason it doesn't work. But if I edit with GIMP and load those into a real image viewing thing, you can actually see that they're alphaed, so that they're kind of like these ground splats that are meant to allow you to kind of build up a little bit of ground as you go. Right? You can kind of see that it's like a little bit of like, this is a little bit of like a stone thing, but it's got some sort of transparency in it. And here's another one, right, that would go on top of that. They'd kind of smush together to make like a stone or dirt area, right? Same with this one and this one, right? So they're just like a couple things that you could smush together to make sort of an abstract, stony kind of texture on the ground. And similarly, I don't know why it opened that many versions of GIMP for me. I really didn't need that many. Similarly, there's like some grass tufts that can go on there, right? I'll go ahead and grab those up. And also some grass that works the same way as the stone, right? Here's some alphid grass things. And so, if you think about kind of how these are meant to work to just build a little bit of background, if I was to cut and paste these in a paint package, for those of you who are familiar with how these sorts of things work, right? If I were to cut and paste this, so I cut and paste a new one in here and make a new layer out of it, right? I can go ahead and sort of reposition that layer, and you can see that when I do that, it sort of looks like, if I go back and look at the image now, it sort of looks like I've extended the grass area out, right? It's like a brush, it's like a stamp, right, that I can use to make things look kind of like an organic texture that goes for a while larger than the original one was, certainly. And here I'll add the other stamp in there as well, right? So here's that other stamp. I'll put that one over there, let's say, and maybe we'll duplicate this layer again, and I'll put that down here, right? And so you can kind of see how, like, if I just duplicate these things, I can kind of make an area that's kind of grassy, but that isn't necessarily obviously repeating. Now, ideally, you're not going to do this with just two brushes like this, right? Ideally, you're going to use more than just that, right? Because you can already sort of start to see, you'll see some kind of patterns in it if you only have two brushes, and that may be a little bit too much. But you can kind of see how that's meant to work. And similarly, like, if I start adding in the other brushes here, like this. Oops, that's not right. My GIMP skills are already in question here. All right, so if you add another one here, you can sort of start to see how maybe you make an area that's got some stone to it, right? And just from using this technique, you can't necessarily get perfect results. There's a bunch of things that we'd want to do, like and again, continuing forward on the stamp front, I could start to even show you sort of a little bit what some of those look like, right? I could start stamping in some of these detail things here, right? To cover like the boundary between them, that sort of stuff, right? Making a few of these little guys here, that kind of come around. And, you can start to imagine building up a world this way. And so the vision that I have for the vision that I have, this sounds like some kind of a Silicon Valley TED Talk. What I am planning to do in terms of requesting stuff art-wise is eventually in the full art pack for Handmade Hero, what we'll do, like what we ship with the actual game, is we'd have lots and lots of these kinds of pieces for making groundscapes, right? So we could put a bunch of stamps in and make kind of semi-organic feeling things that, are able to look non-repeating, but that still have a reasonably high quality level and don't look like a tile map, right? A tile map would have very, rigid boundaries and look very repetitive, and very, rectilinear, because that's how it's constructed. And this is a way of loosening up those constraints and making it so that we can have a little more freedom to make things feel a little more, or a bit more organic, where you can't see the seams as much. And, if we do it well enough, and if the source art plays well enough with it, you can kind of get to a point where it sort of looks like someone hand painted each individual screen instead of it actually being assembled from pieces, right? Now, you probably can never get all the way there because, a hand-painted thing can have a lot of little touches in it that maybe it's too hard to reproduce with these kinds of techniques without going overboard, but it certainly gets you something that looks a lot more distinctive than a tile map, or stated alternately, it's something that lets your artist produce higher quality results in less time than they would have to do if they wanted to use a tile map. Because you could imagine still doing something of this quality level with tiles, just having tons and tons of tiles and being really clever about how the tiles match up and stuff like that. Certainly there are artists who are very good at that. But that's a lot of work, a lot of mental overhead, a lot of dealing with constraints. That's just a lot harder for artists to do. And in some cases, there's things that they just can't do in that way because it doesn't work out, right? And without them basically just painting everything and giving you a tile map that was essentially just a series of tiles that reconstruct pre-made backgrounds. So yeah, so that's basically what I want to do. And so we already have the ability to do alpha blended sprites. And so although it will probably tank our frame rate because we haven't actually written any blit code that works well at all, that's at all efficient, we could still make something that kind of built up some ground this way. So maybe we should go ahead and play around with that a little bit, because that's, like I said, something that's kind of light and fun. It doesn't really bring in anything particularly new. It's just kind of us setting up some stuff to see how that's going to work. And I do want to do that sooner rather than later. And the reason for that is I would like to see what we want to do in terms of pulling these into like sim regions and stuff, because I'm imagining that things like this, we may still want them to go through the entity system because that allows us to use our spatial partition and all that sort of stuff. But we may not want to bring them to the sim region because if they're just background, we may not need them to actually do anything. Now, some things may want to go into the sim region, some things may not want to go into the sim region, right? Like these little tufts of grass here, for example, maybe we want them to go into the sim region because as you walk by them, they like flutter a little bit, or there's like, they react to the breeze. Or maybe that's handled in like a different way, and so these don't go into the sim region, but they do go into some other list that, just has art effects on them, that sort of stuff. And so, we kind of have to have some plan for how that stuff's going to go. And so having some of this in there now will allow us to make better architectural decisions, and it does make some sense for us to play with it in advance of doing the rest of the stuff. So let's go ahead and take a look at that. So what I'm going to do here is I'm going to start by, again, just loading those in, nothing particularly fancy. What I might do here is say, well, we have those loaded bitmaps. I'm going to go ahead and make like two sort of arrays of these stamps for now. Something where we're going to do like a grass. We had 2 grass ones. We had, I think, 4 stone ones, right? And we had those tufts. I don't know how many tufts we had. 3. 1, 2, 3. Yeah, I think that's right. Yeah. Grass 0, 1. Ground 0 through 4. And I guess we had rocks too. We had these little rocks there, right? I forgot about those. Although I don't know that we really need to do anything with those. So we've got the, well, I guess, is any of these like a decorative rock? Those are big. Yeah, those are all pretty big rocks. So I don't know about those. So let's skip the rocks for now, and we'll just use some of those tufts. So I want to load these up, right? And again, we're not dealing with our asset streaming or any of that stuff yet, so we don't care about this code at all. We just want something that'll load them in. And so we've got that code already working here, right? We've already got ways to load those bitmaps in, so I'm going to go ahead and just load them in. Again, just in the stupidest way possible, because you don't want to think about this at all. This is not important. This is not code that will be used at all. We will have some very different way of dealing with art assets in the future. In fact, that's one of our to-do items. So there's those 2 grasses. I'll load those in. We've got those tufts. I'll go ahead and load those in. Actually, you know what? If I was smart, I'd cut and paste after I edit it to be correct. So there's those tufts, right? 2. And lastly, we have the stones. And I'll load those in. Okay. And let's see. Oops. Slight cut and paste bug there. What would a day of programming be without a cut and paste bug, though, at the end of the day, really? So let's go ahead and build that. Make sure that's all good. And that seems all good. And so now I guess what I'd like to do is let's skip, let's not bring anything unnecessary into the problem right now. Let's just straightforward see what we can do with compositing. So what I'm going to do is I'm literally going to straight up just draw that compositing right in here underneath before we do anything else, right? We come into the draw loop here. This was our clear call, right? This clears the screen to that gray that's behind it now. So what I'm going to do is literally right after that, and I'll even just cav it off. I'll basically just say like, draw test or something like this. We'll just put it up there because I think we're going to want to kind of save it as like a thing. It's like, okay, this is how we sort of, when we were playing around with it, this is kind of what we did. So we'll do like a draw test ground, right? And that'll just give us a little function here that we can play in. And then when, since tomorrow we'll probably get back to what we were working on with collision detection, then we can just turn it up. We'll just comment it out and it won't, it won't get run. So I'm going to have this draw test ground function. And the first thing that I want to do is I want to have some way of looking at how these things composite together. So I guess I just want to have that sort of that draw bitmap call. In fact, I don't remember, do we have, we only have one draw bitmap call, yeah, that has the alpha with it, yeah. So this is our only call, right? And that's in screen space, so those are actually using just straight up stream coordinates. Screen coordinates, wow. So yeah, if we're just going to draw this, it looks like I also need that game off screen buffer, which I did not pass, so I'll have to pass that. And then I'm just going to draw a couple of these. I'm going to draw some of them. We'll start, I guess, maybe with the grasses. And what I'm going to do is, you know what? Maybe we'll just draw them at some random locations. So we'll just draw random grasses at random locations for now. And we have that random number table, right? We were doing this thing here. So I could go ahead and just steal that for now. Yeah, and we can go ahead and pull that out later. You know what might be nice too is to sort of make that random number stuff a little more systemic. And maybe that's something we'll do too. So you know what I'm going to do? I'm going to say that that's another thing that we'll probably do today. To do Casey, make random number generation more systemic, right? And we might do that real soon. That might be something we do just as soon as I get this sort of thing loaded here and drawing. All right, so if I want to draw one of these grasses, I'll just draw this grass. I'll draw it at, I don't know, 100 for now, because I don't have any better idea of where I want to draw it. And I want to draw it at full alpha, obviously. In fact, I guess I don't need to include that because we're going to draw it at full alpha. So let me take a look here. Draw test ground does not take test true. So let's go ahead and pass that screen buffer. What is this? And we need to, that loaded bitmap has the width and the height, but we want to specifically get the pixels out of it, I believe. Is that true? I don't know if that's true. What's draw bitmap do? What does draw bitmap take? It takes a loaded bitmap. Oh, I just need to pass a pointer. So that's all good. So I think that should give us something where we actually do see that grass show up, and there it is, right? Now, like I said, it's always just drawing it in screen space. So when I move, it's just going to move with the camera. It's always going to be at the same place on the screen, because we're not even thinking about how they're getting pulled into the world or where they are yet. That's not even on the table, right? So now what I'm going to do is I'm going to try just splatting down a ton of those, and I want to see what that looks like if I splat down a ton of them. So let's go ahead and take the random number generator here. And when I say random number generator, I mean not really generator, because all we did was use a random number table at the moment. Random number generation is sort of on our to-do list of stuff to talk about how you do it and to implement one. So right now we're just using a table of random numbers. So yeah, so I can go ahead and do this and grab one out of there, and I'm just going to say that, you know, we're in pixel space right now, which again is not particularly useful. And in fact, I guess one thing, maybe we want to actually make this not be in pixel space. So we'll use that meters to pixels, for example. So we'll actually make this number be in meters. So we'll do like x meters and y meters, or I could even do, let's see, p, just a position for the grass here, right? And so when I initialize this, what I'm going to do is I'm going to try to initialize this to a value that is going to be within reason, right? I want to pick random points on the screen to draw this grass, and I need to come up with numbers if we're doing our meters to pixels thing. You know, I want to come up with numbers between like -16 meters and 16 meters or something, right? Or -20 meters and +20 meters, something like that, right? But our random number generator, right, whatever the random number generator is only going to produce values within a certain range, right? Because it's just, you know, no matter what we end up doing there, we're always just going to have some random entropy that it produces. And of course, we do have a little bit of a problem here, which is we don't actually know what the range of these random numbers are. We just grab them off of random.org, right? They're just some random numbers that we got. I don't even remember what their maximum value is, but you can see just looking at these, right, that there's no, the high bit is never set in these, right? So basically, like, it's not the full 32-bit range of unsigned integers at all. And in fact, I guess I could look here, 0x765. So it looks like we never have any values that are going to be higher than, you know, 0x500. Yeah, it's, in fact, they don't even use the first hex digit, right? So they're somewhere, I don't know, can Emacs's quick calc do this? What is like one of these numbers in decimal? Oh, it can't do that. Oh well, too bad. I was hoping that quick calc might save the day there, but it didn't. But anyway, point being, yeah, these are relatively small. So what we don't actually know is we don't know what the maximum value of our random number table is. But you know what? That's not a particularly hard thing to figure out. So I'm going to go ahead and figure out what the maximum number is in there. I'm just going to go ahead and say, all right, we've got a max value. The max value is assumed to be 0 at the outset, which is, of course, the smallest value that you can actually have. I'm going to say that I've got a number index and that runs the whole length of the random number table, right? And then I'm just going to say that if, for any given entry in the table, whatever that happens to be, I'm going to say that if the thing that I've got is less than that, then I'm going to keep it, right? Like so. And so, if I go in and actually run that code now, that'll tell me what the largest value is in my random number table, and thus what the largest number is that it could possibly produce. So let's go ahead and grab that breakpoint here. Hello, draw test bitmap, there it is. Let's go ahead and run through that and see what the max value is. So there's that max value. So I'm just going to take that max value and I'm going to put that into our random number generator, right, as a thing that we know. So if I go in here to the random number thing, I'm going to say, maximum random number is that, right? Max random number. I'm not a big fan of the all caps. Why do you have to shout all the time? So anyway, that's the maximum value that can be produced. So what we know then is if I want to produce, right, a floating point number, if I want to produce a float, and what I'm getting back is these random uint32s, right, that I know range from 0 potentially, although I don't actually see 0 there either. I wonder what the minimum value actually is. I probably should have done that too, huh? Let's take a look. uint32 min value equals max random number, right? Or I guess I could even do this if I wanted to be clever. I set it to the maximum, I set the minimum value to be the maximum it could possibly be, so that anything that I hit in the loop will be less than it, and then I'll just always take whichever the least value is. I'll keep them through loops. This is, by the way, a very common programming pattern. If you have never seen it before, if you want to just keep track of a minimum or maximum value while you're processing things, you just set an initial value that's the smallest thing or the largest thing that it could possibly be. And that way, when you go through, no matter what the entries are in your actual set of values you're comparing, you'll always pick out the smallest and the largest of them, right? So let's go ahead and run that, and we'll see what the minimum value is as well. Let's go ahead and run that. Oops. That probably would have worked, I guess, because our reload would have caught that, but just might as well recompile it. So that's the smallest value that there is as well, right there. Okay. So those are our extents. We could just treat that one small enough that we could just treat that one as 0, but we computed it. We might as well leave it in here. So there you go. So that's our range. So what I'm going to do is I'm going to say, all right, let's assume that that we get back one of these random integers, and we know that at maximum it's going to be this value right here. So if I want to produce a floating point number, what I can do is I can take whatever the value is that I would get back, right? I can take that random number table entry, and I can divide it by whatever the maximum is, right? So if I move that up to a float, and then I divide it by whatever the maximum value could have been, I'll get a number between 0 and 1 that is how big it was within the range of the values that we get back, right? So that's a pretty easy way to turn random 32-bit integers into random floating point values. It's very common, right? Nothing particularly fancy going on there. And that's one way that I could create a random point. So that means now, after I have that random point, I've got a number between 0 and 1. Unfortunately, I actually want, if we assume that the center of the screen was 0, 0, for example, which is how we've been rendering stuff so far, if I assume that the camera's pointed at 0, 0, and so what I really want to do is, if I'm trying to, put grass around a center point or something, I would want a number between -1 and 1, for example, so that I could multiply by some radius that I want to put things around based on the point. And so if I want to do that, I need to figure out a way to turn a number between 0 and 1 into a number between negative 1 and 1, right? And so that's, again, pretty easy. That's just scaling up the range and moving it, right? And so the way that you typically think about these things, again, it's second nature for anyone who's been programming for a while, but if it's not the sort of thing that you do, you might not be familiar with it. So I'll just draw it out quickly for people so they can see. So there's day 81 right there. And so what we're doing here is we're saying, okay, we have a number that's mapped between 0 and 1. So it's in here, right? And here is my number line. And what I want to do is I want to take that and I want to transform it so that instead of being between 0 and 1, it's between negative 1 and 1, right? So it actually occupies this range. Yeah? So there's a couple ways, right, you could think about doing this. The intuitive way that you just do after you've been programming for a while is you go, oh, okay, this range is twice as large, right? How do I know it's twice as large? Well, the maximum minus the minimum, right, is 1 minus negative 1. That's the range. It goes from negative 1 to 1, which, of course, equals 1 plus 1, or 2. So the range is 2. In this case, the range was 1. 1 minus 0 is 1, right? So I know that it's twice as wide, that interval. So the first thing I'm going to do is multiply it by 2 to get it so that the range goes from 0 to 2. So now it's big enough, right? So I'm going to multiply by 2. Then what I need to do is just shift it down so that it lines up with the original part, right? And so what I want to do is say, okay, we need to move it down 1, so I need to subtract 1 from it in order to line it up, and then I'm done, right? And so you just intuitively would do that in your head. If you've been programming for a while, you're just like, oh, okay, I've got some function that produces a number that's between 0 and 1, right? And so if I wanted to make it between negative 1 and 1, I just do 2 of it minus 1, and that now equals a range of negative 1 to 1, right? So, I mean, I can't really say, I don't know why these are the sorts of things that programmers just end up doing in their head. I think it's because you do them so often, you just end up, that's the way my brain just automatically does it. So I don't really sit down and work out the math for doing things like that because you've done it so many times that you're just used to it, right? And so you could, if you're doing things like this and they're a little too complicated for you, like maybe not this one, but something that's slightly more complicated, you can choose to work out the math a little more explicitly, right? You could say, something that would give you some indication of what it was going to be. Like you could say, like, I have an f of x, and I want it to map to this negative 1 to 1 thing, right? And you could say, like, all right, what I know is I want f of 0 to map to negative 1. And I want f of 1 to map to 1, right? So here I'm saying I've got this interval 0 to 1 and I want it to map that way. I know two example values, right, of what it is that I'm inputting into this function, right? And so over here, whereas I did it whereas I just kind of read it off and did it by rote, I end up with an equation that essentially is just 2x minus 1, whatever that input function was, right? So we'll call that thing x, because I wrote it as f of x, but really I don't even know why I bothered doing that. It's not really an f of x. It's just the random number 0 to 1 range that comes back. So we ended up with a thing that was 2x minus 1, right? That was the actual equation that we were going to use, and that's the thing that we would type in right here. But if we didn't know what that was, once we have this, we do have two essentially points defined on whatever our function is. And so if we wanted to, we could make up an equation and see what we solve for. We could sort of see what it tells us the result is. And that sounds a little weird, but I'll show you what I mean. So all we have to decide is what type of curve we want, right? Like what type of curve do we want this thing to take? Because we've set two sample points. So we can use those two sample points to figure out what the resulting function that we want actually is. But what we haven't said is what happens in between. So we've said at 2 points this is what it is, but what happens in between? So all right, you told me that when I input 0, I want it to come out as -1. When I input 1, I want it to come out as 1. But what happens in between? Is it, a smooth, is it just a linear progression between those two? Is it a parabola, right? Does it get is it slow and then fast and then slow, right? And you can imagine if I drew the graph here, where I said, all right, I've got that, and just to be a little more explicit, I'm sorry, I feel like I'm not really communicating as well as I'd like to. Just to be explicit, when I say f of x, because I know math can be daunting, right? When I say f of x, what I'm talking about here is the function we wanted to find, right? And I feel like the reason I confused things is because I was using f of x up here. So let me just re-clarify, just to be absolutely cementing it, right? So if f of x is the function we want to find, right? This is the function to find. The x in here, the thing that I'm plugging in, is that output from the thing we already have. So we have a number between 0 and 1, and we want it to go between -1 and 1, right? And so x is that 0 to 1 number that we're trying to transform. That f is transforming into the thing that we actually want, that goes from -1 to 1, right? And so if you take a look at here, if we were to plug in x, so x goes from 0 to 1, that's what we're saying, and we were to look at what happens to f of x, right, where this is, let's say, so this is 1, this is like 0.5, and this is -0.5, and this is -1, right? So we're looking at what's going to happen to this function that we want. What I'm saying here is, well, okay, we've defined what happens at x equals 0, we want it to be here. And we've defined what happens at x equals 1, we want it to be here. But now what we need to tell math, in order for math to help us, is what happens in between. Does it look like this? Does it look like that? Does it look like this, right? What is the shape of that thing? Because math could produce all sorts of things. It could produce a thing that looked like this for all we know, right? So we need to give it a little more information. And the way we give it that information, like what determines that, is what does the function look like? And specifically, what is the degree, right? The degree of the polynomial. And if you remember from your math classes, which hopefully you've had at some point back in grade school, whatever your algebra class was, degrees of polynomial is like if I have a function in x, then the degree is like what's the highest power. So if I've got a x to the 5th plus x to the 4th plus x to the 3rd plus x to the squared plus x plus a constant, and that's my function of x, right? Then I would say that this was degree 5. It's a 5th order, we often say, right? It's a 5th order polynomial. And so what this determines, what that order is, that determines how complex the curve is between those 2 points, right? That I'm asking for. If I say that I only have a first order thing, I've got x plus c equals f of x, then I've got just a line that goes between them, right? But if I was to say x squared plus x plus c, now I've got a parabola that goes between them, right? So it could have like this kind of shape, right? So hopefully that all makes reasonable sense. That's sort of what we're talking about here. So in this case, I don't want any kind of complicated curve mapping between my things. I just want to linearly take 0 to 1 and map it to -1 to 1. So it should be, it should be a perfect linear mapping between those two, so that as I slide x from 0 to 1 smoothly, it slides from -1 to 1 smoothly at a constant speed, no matter where we are in that space, right? And so what that means is that I don't want any of these higher orders in here. It means I'm looking at something that looks like this. And so what I do is I set up an equation that's the most general equation for a function of that kind, and I just go ahead and solve it, right? I said these are my 2 points that I've defined. So now I know my f of x looks like some coefficient times x plus some constant. That's the simplest form. I don't know what these two are. I have no idea, right? I'm just going to let math figure it out. So I plug in my two sample points. I say that f of 0, right? So f of x, that's going to equal a times 0, put a little slash through there, plus b. And I said that if I plug in 0, I want -1. So that's going to equal -1. Well, that means b equals -1, right? I mean, 0 times a is 0. So that means b equals -1. Boom. I've solved my first unknown that I had. And similarly, I can now plug in my second sample point, right? I can say f of 1 is going to be equal to a1, right? Because I plug in for x. And then I already know what b is. I know that b is -1. And that's going to equal 1, right? And so if I have f of 1 equals a minus 1 equals 1, that means a equals 2, right? Because I move the 1 over to the other side. And lo and behold, when I plug those two things in, I get f of x equals ax plus b, or 2x minus 1. And hey, that's exactly the thing that I did in my head in a totally different way, but that's the function we were looking for. So again, like I said, kind of wanted to be light this stream, so I didn't want to do anything where we're going to be getting too deep into the code. So I figured I'd just go off on this tangent here and show you how simple that stuff actually is. Basically, you could do this for any kind of curve that you wanted. If you know enough sample points, and obviously you need more sample points as you get higher up in degree, because, for example, there's this notion, right, of degrees of freedom. You could sort of think of them as where the more power you have in your function, the more, you got x squared, x cubed, x, right? The further you go up, the higher that degree of polynomial, the more degrees of freedom it could be thought to have, meaning the more constraints it can hit on here. If I have an equation in x, well, it can hit 2 points. But that's the most it could have hit, because remember, the equation got completely determined just by plugging in these 2 points. Completely determined. There was no more degrees of freedom left in there. There was no more slack. The equation was what it was. So if I had said a third thing, if I had said f of 2 is 12, well, we'd be out of luck, because either that's already redundant, meaning when you plug in f of 2, you do get 12 out of this. But hey, guess what? 2 times 2 is 4 minus 1 is 3. You don't, right? Or the truth, you're in a situation like that where it doesn't equal it, and then this is not possible to satisfy. So either it's not possible to satisfy or it's redundant. And that opens up whole cans of worms. You can solve redundant systems, and you can also solve over-constrained systems. That's like when you get into things like, least squares and singular value decomposition and all these sort of cool, way out of scope for tonight, linear algebra things. But when you're just dealing with the basics, what you want to basically think about is just how many degrees of freedom you have. And so if you have a equation in x, you've got those 2 degrees of freedom you can hit. And if you went up further, like let's say I went up to squared, I'd be adding another point I could hit, right? So if I went up and I said that I was going to do f of x equals, right, ax squared plus bx plus c, so now it's a parabola, right? Now it's a thing that's going to look like this or whatever, or like that, or who knows what. Depends on the signs of these things. Then now I know, in addition to hitting these 2 points, I could hit one more point, right? I could pick one more point to hit, and it would solve for the parabola that curves just so, right, so that it could hit them. And, by the way, that thing I was saying about redundant or impossible, if you looked at it on the graph, a redundant point for a third point, for if we were back at the f of x equals ax plus b, right, that can solve this line, that can draw a line between those 2 points. Redundant would be if I gave it a third point to hit that happened to be right on the line, right? Now it can do it. But if that point is off the line, yes, I could hit that with the parabola version. The simpler version, it can't. There's no way it can draw one line that goes through 3 points, right? And so what the other linear algebra techniques and stuff do to work this out is other techniques, what they do is they allow you to specify other things you can do to still solve it. So like maybe you say, well, all right, I realize that there's no such thing as a line that passes through 3 points. But what I do want you to do is give me the line that passes the closest total to those 3 points using some metric. So I want you to minimize the total distance between the line and the points or something like that, right? That would be an example of what math could do by elevating up to higher, more powerful math. You can still solve, even though there's no way to do the actual physical thing. You can still get solutions out of these by saying, I'm willing to give a little bit up, and the math will go, okay, well, you tell me what you're willing to give up, and I'll tell you what the best answer is. And so that can still be very powerful, right? All right, so that was a nice long digression. I feel good about that. That kind of cleared the palate. Kind of got me out of the train running over people's mood that we were in when we started. And so what I want to do here is just I'll throw that in there. So that's what we said that was 2 times the input, right? Which is this stuff. Well, actually, I guess I don't even need to parenthesize that. Right, it's 2 times that input minus 1. That's what we solved for, and hopefully we did the math right and didn't make a mistake. So that's the input. We want to basically do this some number of times, right? I'm going to start with just 1 grass index. I'm going to start with 1 so we can make sure it worked, but then we'll crank that number up. And then what we need to do is we need to transform that into something that's centered around the center of the screen, because we'll start there, and that gets the meters to pixels in it. So we want to do this. We might call this actually the offset, not P. And we might say that we had a center of the screen, right? And the center of the screen would be that buffer width, buffer height that we've got in there. Oh no, not height, Tim. So if we take half of those, that would be the center of the screen. And then we can go ahead and just say, all right, we've got the point for our grass is the center of the screen plus the offset scaled by that meters to pixels, right? And when we go ahead and draw that, we need to know the location of it. And so I'm going to go ahead and grab that location out right here. And that should give us a grass at a random location, right? In theory. And there it is. Hopefully that's a reasonable random location, we don't know. And if we were to go ahead again and increase that number, so let's say I increase this number to 10, we should see more grass show up. There it does. It looks like we're not... Oh, right. We forgot to say how many meters we wanted our radius to be, right? So this is a radius of 1 meter, so they're going to be all kind of clustered. But what that does tell me is that really... Oh, and also we're using the center of the screen, which is... We've got a couple more things to work out. We're using the center of the screen, which is we probably want the center of this like world drawing here. No, that's not true. That's not true. We are using the center of the world part we're drawing. So we're clustered around here. And so that seems a little bit off. But you know what? We're also not accounting. We don't have the center point of the bitmap. So that's the other thing that we should probably do is account for that center of the bitmap, right? So let's do that as well. So we have the bitmap center, right? That's going to be equal to whatever this grass bitmap is here, right? So I've got grass 0. What were these called? Oh, width. So I've got the width there and the height. King state grass height. So we'll grab that bitmap center, and what we want to do now, again, is displace out of the bitmap center. Now, I don't know if we added that to the draw bitmap call. I don't think that we did we? No, we did not. So we don't have an offset baked in there as far as I can tell. So we're going to have to do that ourselves. So it's center, that's the location that we're actually drawing at, and then when we actually draw this here, we want to go ahead and displace it from that bitmap center so that we're drawing about the center of it now, right? And so now I feel like that should be more centered. I feel like it probably is, although it's hard to really say. This is kind of an eyeball sort of thing. Looks like it might be a little low. I wonder if I had a bug in there. Oh, yes. I used grass 1 height. That was a little bit of a typo there. I apologize. So that looks more centered. So now I think we're closer there. And now we just need that radius. How big do we want to splat? How big of a thing do we want to splat these in? Let's say 10 meters. I don't know how big that is. We'll just say that's a good amount there. And so we just multiply that offset, that random offset by a thing. And now again, these aren't going to be a circle because we're generating random numbers inside a square. So if we wanted to do a circular stamp down, we'd have to do some extra work. So right now we're doing a square stamp. And so there we go. There's our grasses stamped down. And I don't know how far we can push this before our sort of bitmap routine rolls over and dies. I don't know if you can see that, but the frame rate kind of chugs when you get enough of those in there. And again, that's because we don't have any optimized drawing routines of any kind there. But there you go. They're starting to look okay there. They're getting stamped down the way that we wanted them to be, and so that's fine, right? And we can keep on cranking that number up and just making it super slow. But for our purposes, we don't care. Look at how slow that is. Check that out. Oh, the pain. It'll be fun to write the renderer and start to tackle some of these problems. But there you go. That's what that looks like. And so you can sort of even start to see that it starts to create a grass texture, even just from one. And you can see, kind of how that technique can be effective. And again, when you look at this, the problem that you see is you see those obvious patterns in it. And that's why you kind of need there to be more variability in the stamps that you're stamping down so you don't get that problem, right? All right, so we've got some random points. Let's just make the radius a bit smaller and the number smaller so that we can just see kind of what it looks like on there. And so there's our little grass patch, and off we go. So that's all good. And so we've only got about 5 minutes left. So maybe what I'd like to do now is just kind of clean a little bit of just make a couple little tweaks here to it. And then maybe we'll play a little bit more with it tomorrow because we just kind of got it working. And what I wanted to say was, you'll notice there's a pattern that you see kind of creeping in here, which looks like this sort of a thing, where we're doing, in fact, we did this twice, right? We had a coefficient, and then we had two integers that we were kind of lofting up there. What I like to do oftentimes is I like to provide a constructor, and again, I'm sorry when I use these terms, sometimes I try to correct myself so I don't actually use terms that mean something very specific in other languages. Like if you're actually doing social programming, I don't really mean constructor. This is just a function that returns a value, but it's the thing that we use to make vector2s, right? So whatever you want to call that. I like to make one that makes a vector2 out of integers. So if you pass it, like a int32 x and y, or a uint32 x and a y, and maybe you can even do something like this. Where you can kind of say like, all right, give me integers and I'll do the cast automatically to make that v2 to loft it up for you. And so, it's just this kind of handy thing that cuts down on a little bit of that redundant typing, which, is something you want to do if you can. You don't want to be sitting around. We don't get paid by the number of lines of code that we write, unfortunately, so we can't just rejoice in our cutting and pasting. So, that's a pretty easy way to do that. I don't know if we can just do this. We may get into some hot water with C's casting rules if we do that. We'll try it first. We'll see what happens. But basically, the reason that I like to do stuff like that is because then, that line becomes this line, which is a lot clearer, right? That just looks a little bit easier to deal with, right? And so, again, we can do that here as well. And that's just like a little convenience that I find that it's nice to have, right? So that's good. The other thing we might want to do just for fun, I mean, there's no sense not doing it just at the very end here. We've got about 2 minutes left. Let's go ahead and make that loaded bitmap sort of a parameterized thing. So we'll call that stamp, right? And we'll say that we're gonna grab the grass out there that's whatever the random number table thing gives us back, but it's whatever the random number table gives us back mod 2, right? So we're just going to grab, remember how we do this for putting out integers. We get a random number and then we just say we only want whatever it is, whatever the remainder is after we divide it by the max number we want. So we're going to add 0, we're going to add 1, and we're going to get back one of those loaded bitmaps. And then we can sort of say, okay, well, we'll stamp down whichever random bitmap we picked, right? It doesn't matter what it was, that's what we're going to do. And then we pass that to the function. So now we've got something that's drawing both of them And, you know, that kind of scales up nicely so that we can have a bunch of different grass stamps and they would all work. Now, we could also do something where we pick stone stamps, right, equivalently. We could say if random number table, random number index plus, there we go. We could say that we want to do that where depending on which random number we did, again, doing the mod 2, so it picks one or the other, we'll either grab a stone, you know, or we'll grab a grass. And I could do this, I could make this a little more systemic too, by sort of saying, all right, let's get that array count of whatever the thing is that we were picking in there too, right? And that gives us, or should give us, both the grass and the stone. Although, what did I do? I didn't do that right. If random number table mod 2, get the grass. Why am I not seeing any stone in there? I'm not seeing any stone. Did I make a faux pas? We grab out the stamp. We draw it. What did I do? And we mod by the number, but I never see. So I'm just going to go ahead and say that it equals stone quickly, just to make sure we did do our stone stuff properly, did we not? We did not. Huh. So do I have a typo down in the stone loader, maybe? I don't know. Where is that? Where is that code? There's our stone loader. We loaded up those stones. So what did I do wrong? You guys already know? I assume it's been a slow day. Oh, well, that would do it. It ain't called stone, people. It's called ground. So we just loaded nothing. And we didn't crash because I guess when we load nothing, we just stuff a null bitmap in there, I guess. I can't remember what we decided to do for that. All right, well, that's how that goes sometimes. But hopefully now we've got a mixture of grass and stone. I still don't see any stone. What is the deal, people? Ground. I'm going to finish this up before we go to the Q&A. Ground 0, 0. Ground, it is called that, is it not? Ground00.bmp. So there it is. And that assigns to stone. So it should get in here. Why does it not? You know, you counted. That's why you don't count your code chickens before they hatch, right? You don't count your code chickens before they hatch. My stone is still not working. Seriously, people? Seriously? That is where we are at. What's going on here? There's the grass. The grass works fine. But as soon as I switch to the stone, I get nothing. Nothing on that screen. So why am I having trouble loading whatever that ground is there? Like, what's the problem, people? Ground 0, 0. Oops. So test 2. So I'm going to step into that real quick because I want to know why that ain't doing no loading. And I don't see anything obviously stupid yet. So I'm gonna see. I want to know. Oh, we didn't restart the game. Duh. Loading only happens at startup, right? All right. This time's a charm. I'm gonna count the code chickens before they hatch. Here we go. Bam. That's what I'm talking about. Now we've got that stone in there, right? Yeah. And, you know, what the heck, just to top it all off, you know, why wouldn't you just do this, right? Why wouldn't you just go ahead and say, you know what, let's tuft it up. Let's tuft it. Because we've got the tufts, you might as well use the tufts. That's what I say. So there we go. So yeah, you know, it's not the world's most gorgeous looking ground in the world yet, but you can already kind of see, you know, once we kind of massage this a little, once we get this going, and also, you know, once we give, you know, Yangshin the opportunity to kind of like fill this up with cool sprites and all that sort of stuff, like once we are further down that road, you can kind of see how it's going to look cool, right? Like, it's going to look a lot better than if I was just having little tile maps stamped down, because it'll have this really nice organic feel to it. So I think we're going the right direction with that, and you know, more on that to come later. But for now, let's not belabor that point. Let's just go ahead and say that we will start the Q&A here on day 81. Please, if you could, please make sure to prefix your questions with Q:, so that I can see them. And please try to keep your questions to stuff we did today, or that we were going to do, I guess, or that we had been working on, but not on stuff that we're going to do later, or off-topic questions, because we do those in the pre-stream. If you want to ask an off-topic question, please come back about 15 minutes before some scheduled start time on another day and ask it, and we will cover it then. Cover it then. Yeah. Yeah. Yeah, the fancy auto-load DLL stuff. So one of the things that that I said kind of at the beginning when we were talking about that is I was like, here's the stuff that doesn't do, right? It doesn't rerun the initialization code. You can't have pointers to functions or hard-coded strings in there. And you know, that's just the way it goes. You can fix that, right? You can solve these problems. And one thing that I will say is the problem that we had tonight wasn't really a problem. It took a couple seconds to, a couple minutes to fix, so it wasn't really a big deal. But the problem we had tonight where it's like stuff getting loaded, that actually, when we do the asset streaming, that'll fix itself. Because the asset streaming would take care of that. It would look and see, oh, I don't have something, and it would go grab it. So really that part is not too big of a concern, because really the only reason we even see problems like that at the moment for those loading things is because we don't have real loading code yet. So those two things will end up working together, if that makes sense, where you'll end up having the auto DLL loading right now is actually weaker than it could be, because it's not backed by any other systems that are helping it. So there's that. Is there an art team working on this game? There is an artist working on this game. But since I have to be so slow, I can only program 1 hour a night. If we actually had an art team working on this game, oh my god, they would be so far ahead of me, right? Like, because they can work 8 hours a day and I can only work 1, right? That's not good. So there's one artist working on the game, and that's a pretty good balance, I think, because I can't go very fast because we cover everything on the stream. So, you know, if there were any more than one artist, and she's only part-time, if there's any more than one artist, they'd be way too far ahead. Memoizico says max random number should be set to fixed number 10000000 because in episode 35, when you went to random.org, you chose to generate random numbers from 0 up to that number. So yes and no. If you it depends what your goals are. If your goal is to make a fair random number generator, I agree with you. You need it to be whatever the range was for the random number generation. But if you want to fill space, then no, you want the random number generator to sometimes be able to produce the maximum value, right? Which in our case, it would actually be able to do. I don't know if that makes sense, but so that's why I think it's actually better to use whatever the actual maximum was. But yeah. Obviously that wasn't a serious comment. What wasn't a serious comment? Pseudonym 73, what wasn't a serious comment? But on topic question comment, do you want to mention tangents when designing curves? Probably not now, because they don't really mean anything in the context of the thing we were doing. So I'd rather save that for some time when we're talking about, like maybe when we're doing animation, because it would be a little more natural to bring some of that stuff in, because there's a lot of stuff we could talk about as far as solving for functions there, and it's like we don't really have anything to motivate tangents in that example, because it was just a simple linear mapping, Panic00, would you ever actually use a higher degree polynomial interpolation? Aren't there better ways to make interpolating curves that are more stable? Okay, it depends what you're asking. So I'll answer the question you probably aren't asking, but just so it's clear to everyone else, and then I'll answer the question that you are asking, I think. But the question that you were asking is, would you ever use a higher degree? The question that you literally asked, that maybe you didn't mean, was, would you ever actually use a higher degree polynomial interpolation? And the answer is, there's no such thing as interpolation that isn't higher degree polynomials, or the one we used, right? Like, anything that you could name pretty much that was an interpolation is a polynomial interpolation of some kind, right? Bezier curve, that's polynomial. It's third order typically. Sometimes it could be second order, right? B-spline, same old thing. That's usually a third order, could sometimes be second order. There's rational and irrational ones, but they're still that order, right? So yes, do you use those higher ones? Absolutely. The standard polynomial you use in most animation interpolation is ax cubed plus bx squared plus cx plus d, right? That's the standard that you're going to use, the standard polynomial form, right? And you don't see it written this way because you see the terms arranged for efficiency in terms of evaluating, Bezier curves or something like that. But it's still a third order polynomial. That's what a Bezier curve is. A Bezier curve is a third order polynomial. Now, I'll answer the question that you were probably asking, which is not what literally got said, right? Because, I know it's chat, right? It's hard to actually be specific about the question. It's not a great way of trying to communicate, right? So if you take a look at this, what I was talking about was solving for those points. That procedure, the solving for endpoints procedure, that is not typically used for interpolation. And the reason that it's not typically used for interpolation is because if you don't leave any extra degrees of freedom in your solve for something called fairing, which we're getting kind of off topic here, but it's okay. It's on topic of game programming, just not what we were doing today per se. If you don't leave any extra degrees of freedom, what happens is your functions do very undesirable things in terms of interpolation. So for example, let's say you were going to use a third order thing and solve for it the way I did. So you have third order so you can specify 4 points. Remember, linear is 2 points, quadratic is 3, and cubic is 4. It's always 1 more point than the degree that you have, right? And you can see exactly why that is. It's because there's a constant. So you're solving an equation in however many, whatever the order is. If it's third order, you're solving an equation in 4 unknowns. Coefficient on x squared, coefficient on x cubed, coefficient on x squared, coefficient on x, and coefficient on x to the 0th power, right? There's x to the 0 here, which is the constant. X to the 0th is, of course, 1, right? And so if you take a look at this, and you say, well, I've got 4 unknowns, I can plug in 4 points, right? So you go like, I want it to go here, and here, and here, and here. Now, any sane person takes a look at that and goes, oh, no problem, I'm going to produce the interpolation that looks like that, right? Of course you would. But what you don't realize is actually there is no third order polynomial that looks like that passes through those 3 points. There's some other polynomial that does, potentially, but not third order. The third order polynomial that passes through these points actually looks like something ridiculous, like, this sort of a thing. I mean, it wouldn't have two bends in it, but it's, it's like that, right? That's the third order polynomial that actually passes through them, and that are not what you wanted. You wanted a nice smooth interpolation. What you got was something that hit the exact mathematical values you input with a third order equation. And that's just a limitation of that sort of way of stating the problem. And so typically you don't do this. If you are trying to fit curves to things, you use extra degrees of freedom and you do what's called fairing, which is basically saying we're going to put into the solve, depending on how we choose to formulate it mathematically, we're going to put into the solve the notion that we do not want extraneous wiggles or things like this, right? And there's a lot of different ways you can do that. Like one very simple way to do that is, remember I was sort of telling you about that thing where I said like, oh, okay, maybe there's no way for a line to hit these 3 points. Remember I said that up above, but I can formulate equations that give me like a line that passes, as close to the 3 as possible, so I can get that line out of it, right? Well, the same is true for more complex interpolation. If I was to say, I want you to use a parabola to hit these points, well, a parabola is x squared plus, ax squared plus bx plus c, right, equals 0. That's my parabola, right? So if I'm going to solve for these 3 things, if I use, again, more advanced math, and I use like a least square solve or something like this, I'm going to get, by plugging these in, I'm going to get a parabola that actually pretty nicely approximates those things, right? And the reason that happens is because the system now has the math has a lot more information about what you actually wanted, right? Up here, all you told it was hit these 4 points, and it's like, hey man, I hit them, right? Let's go get ice cream. But it didn't know that in your head you were imagining this smooth curve, because nothing in the problem statement said what smooth was. You just had a preconceived notion, right? And the math doesn't know what your preconceived notions are. And so one way to fix that, like I was saying, is add that information in. And so one thing you can do is use more advanced solving techniques, not like the straightforward literal equation solving we were doing here. Ones where you're going to solve systems of equations that are more complicated than this, even though we're still only trying to find a parabola. And what we're going to do is say, let's specify those points we're trying to hit, like these 3 points, let's say. But instead of it then producing this kind of nasty thing that maybe we didn't want, that has extra wiggles or whatever, we're going to add more points in so it knows that we want it to follow this path, right? And parabola is probably a bad choice because usually the wiggles, a parabola can only curve once, right? So it's usually, you usually need to be up in the x squareds before you start to see those extraneous wiggles, right? But you can still have them. It's a long story. This all gets into a lot of animation stuff that maybe we'll talk about at least some of it when we're doing the animation stuff. But so point being, what you may have been asking, and so I wanted to answer was yeah, do you want to do this solve for advanced interpolation stuff? And the answer is no, you don't. You need to do more advanced styles of solving. But when you do those advanced styles of solving, you're still working with the same equations. You will still solve for this equation. You just won't be solving it as directly. So the answer to the literal question you asked, would you use higher order polynomials? The answer is yes, you absolutely would. Just not, you wouldn't find them through the same route that I was saying, right? Hopefully that makes some sense. All right. Let's see. What sort of optimization would you do on that ground stamping? Well, I mean, the answer to that is we're going to see exactly what kind of optimization I'm going to do on that ground stamping, because that is the way that I plan to do the actual backgrounds for this game as we go forwards, and we need them to run efficiently. So the answer is I will probably take 2 different approaches to it. depending on whether we're running under hardware acceleration or not. When we are not running under hardware acceleration, what I'll probably do is use a compositing buffer so that we only do the ground stamping once for any area as it comes into view. And then, so it was sort of like a sort of a rectangular update scheme where as we scroll around, we only fill in the part we need. And then as it comes out, as you move away, we kind of jettison whatever parts we don't need. So it would kind of be like a tiled updating scheme so that we don't every frame re-stamp the whole ground area, right? We're only re-stamping a little new bit of it. And we'll probably stick that on extra threads, potentially. That might be something that we have threads working on to speed things up, and that sort of thing. Now, in hardware land, we have a lot more horsepower to play with. And so what I'll probably do there is we might still use a caching scheme like that, but that's on the GPU, so that we're doing that stamping on the GPU into a texture that we can reuse, so we don't have to do all that blitting every time. But a bunch of things we just won't blit in there. We'll blit them every frame, such as the little ground tufts, so that way we can have the grass kind of respond to wind and that sort of stuff. So it's not pre-composited in. So basically we'll try to look for opportunities to use that extra GPU horsepower to do something cool, but we'll have a scheme that works for the software renderer so we can kind of learn about how that works, right? You aren't treating both ends of the random numbers the same, but the current system you can get 1, but you will never get 0 because you are not considering the min. Though perhaps you're getting close enough to care. Yeah. So again, I wasn't really being particular about this. Even the max one, I wasn't really being particular. I just wanted something that would roughly work. So when maybe we could even just go ahead and talk about the random number generator sometime soon and actually put in a real one. The real one is not going to have these limitations. And so in theory, this is all kind of not that useful. But yeah, we could easily say, all right, if we know, if we wanted to make this so that you could actually produce 0 out of it as well, what you would do is you'd say, okay, this equation here, right, where I'm dividing it out. So I'm producing a number between 0 and 1 here, but we know that it'll never actually be 0 because we know that random number table can never return a 0. What we would do is say, oh, okay, well, whatever it does return, we subtract the min from that. So now that we know it does go from 0 to the max minus min, and then we divide by that new, range. So it'd be very simple to add that in, but again, I don't really super care about this at all right now. And this random number table is not something we actually want to use in production. It's just something to avoid having us have to discuss how to generate random numbers right now. Or more specifically back when we first put it in. But we will be talking about how to generate random numbers, and then we'll have a random number generator, which will have more of an opinion about how it produces its numbers, and we'll make sure it can produce all the numbers between 0 and 1 that are floating point, Let's see. Do you plan on having things like dirt paths, and if so, would you draw them using splats and stamps? Yeah, I think we will draw them using splats and stamps, but again, certain elements of the ground might have to have additional logic. We're not going to just throw stuff on the ground like this. This is just to get things started. So when you're talking about things like a dirt path, or maybe more interestingly, a dirt path isn't perhaps all that useful because that's a very calculating itself. But let's say cobblestone path, something with a regular pattern on it. When we find ourselves wanting to implement stuff like that, we will have to be more careful about how we are doing this stamping process if we want something that's going to be a reasonable result, right? And so certain things are going to be harder to do than others. Now, maybe what we'll decide is we just don't care. We don't want to spend the time on that. We'd rather spend the time on something else. So we won't do that or something. But assuming we get to the point where like we really want a nice, cobblestone path in here, and, just randomly sort of throwing down stamps is not going to do that. We got to start thinking about how we're really going to align things and do things in a useful way there, right? So we'll attack those as we come to it, but we will still do some kind of procedural generation for them. It may just not be, it may not be such a free-form stamping as what we sort of started with here, right? So your ground texture design is essentially mega texture. No, I wouldn't really call it mega texture. I mean, so there's a lot of elements to mega texture, assuming that you're talking about id Tech 5. And we're not really using sort of what I would say is so we really need a way to take polls is what we need. Because I can explain to you exactly why this isn't mega texture, but I'm not sure if that's actually something that's interesting to people. Like, because, mega texture is like this esoteric thing John Carmack made, and, explaining why we're not that is maybe not super useful, but yeah. Based on the screen, it appears that you need to know math to do this type of activity. Is that correct? That is correct. Yes, you do need to know math to do this kind of activity. Try to look for any more on-topic questions. Again, for people asking stuff like, did you learn higher level concepts from university or elsewhere? Those are good questions for the pre-stream if you want to come back tomorrow. Anytime before our scheduled start time, we're at 8 p.m. tomorrow. So if you come at like 7:45 and ask questions like that, we do random questions that aren't that aren't specifically on what we're working on. Anything else? I think I got everything. So I guess I'll try to explain in 3 minutes, since there are no other further questions, the on-topic question. It was totally on topic of whether the ground texture design is essentially mega texture. I'll give it a go for you. All right. So this was my plan over here, and this is mega texture over here. So my plan was simply to say, all right, we've got a screen, right? And so I'm just going to assume that that screen is, broken up into chunks that I want to compute, right? Like so on. And I'm just going to say, all right, for any given screen, let's see what the chunks are that are available. Let's see what the chunks are that are visible, right? So again, it's very much like what we do for our entity spatial partition. It's the same thing. In fact, we could even tie it to that. It could actually be in the tile chunks. We go and say, did we produce this one yet or not? And do we have it like in a cache, basically, or not? If we do, we just draw it. If we don't, we say we need to generate it, right? We generate it and we store it for future use. Really, really simple. That's it. So I'm just talking about looping through those things, and then basically, if you think about what we've got, there's basically a cache of these things, right? Entries. And so we look through here and we say, okay, to render this, we need, we need A, B, C, D, E, F, G, H, I tiles, right? And in the cache are A, C, E, G, and H. So it goes like, okay, got to render this tile. Do we have that A? Yeah, we've got it. Put it in there. Great. All right, we've got B. Do we have that? Put it in there. Great. And I may not even go that far, right? I may just say, all right, you know what? This is way simpler than that. We don't even have to worry about that, really. We've just got a screen's worth. So we know we had the screen filled on the previous thing. We now know we moved some amount. So then, we moved the screen. So basically, like, this is the part we have filled, but this is the part we need to view, which means that this part we still have, right? So we just draw that part from before, and then we just fill in this part over here, right? So it's like a dirty rect updating scheme. So we might even be simpler than even that, right? Megatexture has a lot more to it. What megatexture does is megatexture says that essentially there's just one giant image, right? And that giant image is broken up into tiles. So it looks sort of like the scheme at the head end. But first what happens is you allow the GPU, right, or whatever the rendering system is, to first do a pre-pass. So, so step one is you do a pre-pass on the screen and you draw everything, right? So you actually draw, the game with the hero and the little sprites and whatever there, right? You know what I mean? And then you say, okay, when we do that drawing, instead of actually drawing the color values we actually want, instead we just draw, IDs. We draw something that tells us what we would have needed to sample from in terms of textures, it's sort of bitmaps, for each individual location, right? So this thing doesn't look at all like an image when we draw it in step one. It looks like a total mess of colors, right? Because those colors are actually IDs that tell us things. We then look through that and we say, like, okay, find all the IDs in the cache, right? So we say anything that showed up on the screen, then we look at the cache, this thing, same sort of idea, A, B, C here, right? So that part's similar. Find all of those, right, and use them. But unlike this scheme, they're not actually laid out as a cache, if you will. They're laid out as an image. So they're laid out in a scheme where, they're in there. This is really hard to explain. This is going to take too long. All right, so that's not actually true. You could implement megatexture with us. So let's just go with it. I'm not going to say how they actually do it normally because it's actually laid out in a texture and there's other consequences to it. But let's ignore that because that's kind of a GPU thing. So let's say they were in a cache, right? You find all the ideas in the cache, but the key thing to understand is, unlike my scheme, where there's just some number of things, I was saying, there's 64 tiles in the cache and that's it. So you found it. If not, you throw something out of the cache and you pull in, you make a new one, right? And you put it in there. That's not what happens here. All tiles are in the cache all the time in megatexture. So you will always find the ID that you wanted, the thing that you wanted, will always actually be in there. The question is just what resolution. And so what megatexture does, if you think about it, it starts with like one 4096 by 4096 texture or something, right? Or whatever the size is. I don't know what the minimum size is. Maybe it's smaller than that. Maybe it's just 156 by 256. You could implement it however you wanted. It starts by saying, when I start the game, I have one 256 by 256 texture that's already like a tile. In fact, yeah, I guess you would probably implement it that way. Whatever your tile size is, you'd say, I've got one of those that's the whole game. Every image in the game is in this 256 by 256 texture, right? So it's all packed in there where like this one pixel represents like a whole town or something. The average color of like a whole town, right? I'm not really exaggerating. This is actually how it works. And so then what you say is, all right, the cache is not little tiles that correspond to things on the screen. The cache is like multi-resolution. One of the tiles, which may never be evicted, is this uber tile that has the whole game in it. So if I need to look up ID 63, right? Well, if 63 doesn't exist at a high resolution, or a low resolution, or any resolution really, I can always fall back to whatever texel coordinate it was in this 256 texture and draw the thing at its average color for the region, right? So there is no failure case for this. It just gets lower and lower resolution, right? And then when I do fail to find something in the cache at the resolution I wanted, so I'll always succeed in finding it, but I might not find it at the resolution I wanted. So this ID of 63 also says like, oh, it's 63 at detail level 7, right? I then say, okay, evict something from the cache that's like a least recently used thing or something like that, and go load this one so that soon I will be able to draw it at the right resolution. So the cache ends up actually being this sort of this thing that stores things at all kinds of resolutions, and you're constantly sort of putting new things, fresher, lower or higher resolution things in there depending on how you are trying to manage that cache out, right? Does that make some sense? So I'm sorry I didn't do a very good job explaining that. I would really need a long time to explain megatexture, but it's not really this. This is much simpler than this is, and really, this is not a good choice. Well, I might argue this is not a good choice, period, because there's reasons that megatexture is not a good design, in my opinion. Like, I don't think megatexture was a good idea, if that makes sense. But even if you thought it was a good idea in 3D, I think you would really say it's not a good idea in 2D, because what this is designed to handle is the fact that you don't really know ahead of time what the bitmaps are that you're going to need, because 3D is so complicated and you're looking over vast vistas and then down at the floor and all these, right? And so it's trying to manage that level of detail stuff really cleanly. That's its goal. We don't have that. We're a 2D game. We know that everything is basically going to be the same resolution. You don't get this sort of long view distance, close up zoom thing happening. And so we can pretty much just know we don't need multiple resolution versions of these tiles, really. We know exactly the resolution we're going to need all the time, and we know it in advance. It's like the stuff's coming over here. So there may be some places where we have to work through it, like with animations where we're not sure exactly what we're going to need to load or something. There may be some parts that are a little bit trickier for us. But on the whole, it's just not the kind of situation where we need that dynamic level of detail fungibility that megatexture was designed to give you. And furthermore, we certainly don't need this step. Although you could argue that, well, you could still maybe call it megatexture even if you don't have this step where you draw and see what IDs. But we definitely don't need that because we know exactly all the stuff that's going to be drawn pretty much. And we just we don't have the kind of things occluding other things, or the backs of things not being visible. We don't have much of that in a 2D game. We kind of know what's getting composited, and we know that if it's not visible right now, it'll be visible soon, right? Whereas that's not the case in 3D. So hopefully that, I don't know, maybe that answered that a little bit, but there you go. Why do you think John Carmack is a hack, and when are you going to say it to his face? I don't think John Carmack is a hack. I think John Carmack is one of the greatest game programmers that's ever lived. I just think, like any programmer, even the greatest programmer that ever lived, doesn't always hit the mark. Megatexture just wasn't a great scheme, right? And, maybe he disagreed with that. Maybe he thinks it was successful. I just don't think it was a good design. And that's easy to say in hindsight. He doesn't know going into it. I mean, he invented the thing. And a lot of times when you make something, when you're working on it the first time, you don't know if it's going to be good or not. You've got an idea and you think that something could work, but whether it actually pans out in the end exactly the way that you'd hoped, and whether it solves the problem you hoped it was going to solve in an elegant way, it's very hard to know with something especially as complicated as megatexture, and in an environment like a megatexture was being developed where GPUs were a lot more primitive than they were today. It's just very difficult, right? And so John Carmack has made a lot of very good engine design decisions throughout his career, and so hopefully I would think he would not mind me saying that one of them was not particularly good, because, I mean, the guy's got a very long track record of very great designs behind him, and yeah. Not only that, but John Carmack, he ain't the most emotionally volatile dude out there. And so even if for some reason he was paying any attention to what I had to say, which is unlikely in the first place, he doesn't care, right? In fact, what he would probably care most about was that I didn't do a good job explaining it, because he's a kind of technical fellow. And so that would be the thing. He'd be like, yeah, you didn't explain megatexture very well. I'm like, yeah, I know. I was under time pressure, man. But what I can say is also, if you do want to learn about megatexture more specifically, I would encourage you to go look up sparse virtual textures. There's a video by Sean Barrett, @nothings is his Twitter handle. Sean Barrett. He has a whole video where he shows how they work, and he does a great job explaining them. And he also covers the actual minutia of it, like how you do MIP mapping on it, trilinear and padding and all that sort of stuff. And he ships sample code too. You can go download sample code. You can just see. You can be like, here's how megatexture works. Here's a complete working example, right? And so I would highly encourage you that if you were curious about actually not, a better explanation than what I gave for how megatexturing works, I would highly recommend that you check out his lecture on that, because that will totally clear it up for you. So there you go. All right, folks, that is the end of another hopefully non-regrettable incident, another episode of Handmade Hero. So thank you all for joining me this evening. I'm glad I was able to make it home in time to do the stream. It was fun. I'm glad we did something kind of light and fluffy that kind of cleared the mood for the day out for me. So now I can go to bed a little happier, and that's good. So again, if you are somebody who wants to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code. So if you want to play around with the stuff like we talked about tonight, you can go ahead and do that. You can pre-order it on handmadehero.org. It comes with the source code. You get a link in your email. Save that link, because you can download the source every night. So every time I update it, you can re-download it again. So don't forget. So that's a good thing. We also have, if you want to support the video series, if you like it and want to support it, you can always subscribe on our Patreon page as well. We also have a news and forum site that community members contribute to. It's got forums on there where people answer questions, and I answer questions too. Sometimes I get annoyed and post annoying things, but most of the time I post good answers, okay? Most of the time I do. And then we also have a schedule bot, which tweets the schedule at you. So if you want to know when the streams are coming up, you can check that out, and it keeps you up to date. So definitely check all that stuff out, and hopefully I'll see you back here again tomorrow night at 8 p.m. Pacific Standard Time, actually Pacific Daylight Time. I think they coincide. I don't know how time zones work. I think they're made to be maximally confusing to everyone, but it's at 8 p.m. on the west coast of America, whatever that time zone is called right now. PST, PDT, something. And so I hope to see you here for that. It would be nice to get another night of programming in with you, and we will maybe play around with that ground code a little bit more, because I wasn't quite done with just kind of fussing with that. So I know it's not really what we're supposed to be doing right now, but we'll do a little. Maybe we'll just make this week be playing a little, and then we can start back on the collision detection finalization stuff next week, where we're trying to clean that up. So anyway, thank you very much for joining me, and I hope to see you tomorrow. Take it easy, everybody.